All right, guys, this is your STAAR review booklet. The cover page kind of has some images of facts or concepts that you need to know. And so what I want to give you time to do right now is to look at these images, look at these symbols, look at maybe the graph, maybe look at your slope band, and see, just write down anything you might know or recognize. We have some lines intersecting right here. Just kind of record any facts that you just know right off the bat, and try to see. Let's see what you have already in the bank, and just kind of give you some hints. So I just want to pause the video. You can pause as well. Put the information down, and let's check what you should hopefully recognize. All right. So the slope guy here, or your slope tree, is showing you a way to memorize your 4 types of slopes. So this was positive slope. We got a plus sign here, or increasing here, positive slope, negative slope. We have undefined slope, that's the vertical line, and horizontal slope, that's zero. A horizontal slope is your zero slope, horizontal line, zero slope, sorry. And then here, I hope you recognize your slope and your y-intercept whenever we have slope-intercept form. So I'll just show that right there. And this is another way to get the slope. So the symbol M is also represented using counting your rise over run. And we have a positive slope, which is increasing here. Our symbols, we have greater than or equal to. I just kind of put the symbol to add on to that. Less than, and this is less than or equal to. Hopefully we saw lines intersecting. The intersection is the solution. These were showing parallel lines. That's our symbol for parallel. This was perpendicular lines. Upside down T is our symbol for perpendicular. And this is function notation. F of x is how we say that. And then this graph on the left was an example of an exponential function. We know it's exponential function because x is the exponent. Exponential functions have asymptotes. This is where the curve flattens out. And it's always a horizontal line. So it's always going to be y equals. And then over here to the right, we had an example of a quadratic function. That's always an exponent of 2, power of 2. And these are the parts of the quadratic function. So we did have some people also add like your vertex in this example would be a minimum. Okay. Axis symmetry, the equation of this line right here, since it goes to the x-axis at 1, this would be x equals 1. Okay, so that, I forgot to put the equation for the asymptote over here. This is y equals -4. So yeah, so these are some facts that you could add to your book. So please get that updated, and we're just going to go straight into our first objective for our STAAR exam, which is RC1, or objective 1. Okay, so I'm going to highlight the sections, objective 1, to indicate where each section kind of starts and ends, and then we're going to look at some example problems in each. So objective 1 here is algebraic methods, solving equations, functions, polynomials, and exponent rules. Okay, so some of the words you might see associated with these type of problems are equivalent, expression, or simplify. Now this is just what we have here are some like calculator tricks or some problem solving tricks, so strategies you can use to help you get to your solution if you're not good with the algebraic method processes that you're going to use. So on this first example here, we have an example. It says which expression is equivalent, there's that keyword, to the binomials, the x plus 3 times x minus 4. So if I'm given an expression, whether it's a binomial or multiplication, I can put, sorry, gotta get my pen. I could put this expression as my y1. So it's telling right here, step 1, give the expression as y1 into the table, into your calculator, and then my answer choice, A, which it says x squared minus x minus 12, that would be my y2. And what you would do is you would put both in the calculator, they put all three here, but what you're looking is to see which one are exactly the same. And so since the first answer choice A equaled our expression in the problem, then that is equivalent. If it's equivalent, it's equal, it matches, they're exactly the same, so have an equivalent relationship. Now for simplifying or algebraic methods, you're going to still have to know some just pencil paper processes, which requires you to know adding and subtracting expressions. So if we're adding or subtracting, we need to add or subtract the coefficient. So we need to add that to our notes. And then it says the like terms, we're going to do the coefficient of the like terms and do nothing to the exponent. Sorry about that thing popping up. I don't know why it's doing that. So we always put in standard form. You always start with the highest exponent, which are our x squares. 3x squared and this minus 2x squared is going to leave me with just x squared. The next highest would be a power of 1. This x has a power of 1. Well, usually that 1 is invisible, so that would be plus xy. And then we would have our y terms, negative 2y and a negative 6y, we get minus 8y. And so this would give us our simplified expression. Now, when multiplying, the thing we want you to make sure you recognize is that when multiplying coefficients, you're going to end up adding the exponents of the like basis. So another way to kind of tackle a problem like this is to distribute each term. All right, so what I'm referring to is like in the binomial here, the first term is x, and I can multiply this x to each term here, x times x squared times my minus 2x times 6x. So when I simplify, x times x squared is going to give me x, sorry, I thought my hand was written, x to the third power, x cubed. Then we get minus 2x squared plus 6x. Then we can go to the next term, which is this 3 times x squared, which is 3x squared. And then 3 times minus 2 minus 6x. And 3 times 6, which is 18. And I probably should have moved that. So sorry, I ran out of room there. Yeah. All right, so then from here, we're just combining like terms. We want to start with the highest exponent. And our highest exponent is this x cubed. Then the next highest would be the x to the second power of the square. So this minus 2x and plus 3x. Going to leave with this positive x squared. Then I have plus 6x and minus 6x. Well, that's going to cancel. And then I have my plus 18. And then that's our final answer. All right, so what I wanted to give you an opportunity, so this is just some pencil and paper skills that you needed to know, and then there's your calculator trick. So I wanted you to give an opportunity to try these STAAR-like questions. You can use any method, and let's check your understanding. All right, so I'm just going to pause real quick, see how you're doing. All right, so number 1, you should have got C. I just realized something. All right, so if you were going to do pencil and paper, because we have 2 binomials, you would have to use the FOIL method to check to see if it equals the expression given. So like first times, sorry, let me change my font here. So first times first, this would end up being 8x. First times last, that would be plus 2x. And then then the inner, this would be minus 12x. And then the last right here, sorry, this would be negative 3. So right, as soon as it gets to that negative 3, I see it doesn't match. So then I can basically cross out this answer choice. And then if I do that for each, I want to match it. Or if you're going to use your calculator trick, so like I'm going to turn off, actually not that one, the second answer choice. And turn this one on. So I have the first given expression, and then I have, this is answer choice B, this was A that we just canceled out. So you can go to your graph to see if it's on top of each other, and I can see that physically isn't. Or you can, if the graphing is hard to see, I think it's best to look at your table to see if it matches. So that doesn't match. So what I could do, I'm going to delete that and go to my answer choice C. Type that in, 2x minus 1 times my 4x minus 3. And then go to my table. And if they match up, which they do, then that's an answer choice. Okay, so that's using that strategy. Here, to simplify this expression, you got to hopefully see this invisible 1 here in front of the parentheses that we're going to distribute. So this becomes, I'm trying to think, 3x squared, then plus 4x minus 2x squared minus 3, but now I'm distributing this negative 1. So then minus 6x, distribute that negative 1 again, minus 2. And then here I can combine my like terms. So that's an x squared, combine my x's, that's minus 2x, and then combine my constants, that's minus 5. And so this was A. And then for radicals, you can put that in the calculator, but it's not y equals. You have to just go to just regular numbers and clear that out. And to do the square root, that's second and then x squared, and we put 48, and we get approximately 6.9282. And then I can check my answer choice 1A, which is, oops, not that. Let me clear that out. 16 root 3. So I get my radical, which is second x squared. And if I put that, I'm trying to see if does the decimal matches. It does not. So if I go to the next answer choice, it does match, and there is our solution. Okay. All right, so then you might see some functions. So we just kind of recap some things about functions. So I'm going to the next page, and it says right here, this is important. So I'm just going to start this. If I see the word function or f of x, then we want to look at the table or analyze the graph, okay? So some things about the function we have to remember. It's a function. What is a function? Is when you have no repeating x's. Okay. So I can check that on the table. Looking at the first row, it's always going to go x then y, and none of the x values repeat. So this is a yes. I can check the x coordinates in a set of order pair. We have 3, 7. Here we have 2 10s. So that's a no. Okay, the x coordinates cannot repeat. Now for vertical, it says right here you're going to use a vertical line test. Meaning if you draw a vertical line through a graph, and if it touches it more than once, it is not a function. I could draw a vertical line against my horizontal line. It only touches it once. So yes, it is a function. Now for verbal, you're just trying to determine if it's a dependent relationship. Here, number of floors and the height of the hotel. Well, that height does depend on the number of floors. The more floors I have, the taller my building is going to be. Okay. And each student in the school versus their age, no, that is not a function. And symbolically is going to be an equation. And hopefully you recognize that this equation is a vertical line. So we got to think about that. If I'm doing the vertical line test, so like we have a vertical line like that. I'm just going to add an x and a y axis. Okay. If I have a vertical line, which is my red line, and I do the vertical line test, put a vertical line on top of it, well, that vertical line touches everywhere. So this is not a function. Okay. And then I can check my mapping here, and this mapping is yes. If I'm checking for not a function, the mapping should split from one x value. Right. So from there, these facts we want you to apply on a graph. We need to make sure we understand function notation is when we have the f of x, and your y equals 3x. And function notation would be f of x equals 3x minus 2. Okay. So just remember that your y equals the f of x. The y value is the same as the f of x. All right, so on this first one, I want you to come up with the y value, because if I'm looking at function notation, which is f of x, like that, what's inside the parentheses represents the x. So in this problem, x is -4. So if I go -4 on the x-axis, we need to get a point on the graph, on the curve. That point is -4, -1. So my output is a -1. Okay, you want the y value. All right, so think about this if you're doing f of 0. X is 0, there, right there. So hopefully you got your y is 4. All right, so given we have just the function h of x, what is the value of h of a -3? So here's our steps if we want to use a calculator. Anytime I see function notation, I can think of it as y equals. So we're going to put the equation in the calculator, and then we're finding h of -3. So that is when x equals a -3. So that's what they're showing right here. If I look in the table, find x is a -3. The output, the y value right here, is 9. So our answer is +9. Okay, so this is just that means your y, your h of x is your y, and y equals 9. These are the same. So this is just kind of reviewing a little calculator trick to help you in knowing the parts. Besides function notation, the next page, you need to make sure you understand if you see exponents, okay, that's the subscript at the top of a variable or a number. Okay, example of an exponent would be x to the 3rd power, which means x times x times x, x 3 times. So if I see an exponent, we need to get in a habit of using our formula chart, and we're going to use the property of exponent rules. Now, this is what basically this side and the right side and the left side is what's on the formula chart that you'll get to use on the test. We just got to understand the rule for each. Hopefully we can read what they're showing. So the product rule, this is meaning multiplying powers or exponents. So like here, this is trying to show multiplying the exponent. The base of a, they're like bases, a to the m times a to the n. Well, you just add the exponents together. So anytime we multiply, we're just going to add the exponents. I'm going to abbreviate that, exp. So if I was to work out this example here, numbers you still multiply together, so that's 12. Then I have x squared, x to the 4th, add that together, that's x to the 6th, and this would be y to the 4th power. Now, your quotient rule, this is just whenever you're dividing, okay? Sometimes our dividing is written like a fraction, and then whenever we're dividing, we're subtracting the exponents. All right, so in a situation like this, my numbers I'm just simplifying. 3 over 12, or 3 divided by 12, reduces to 1/4. Then I go to my a. There is no other a, so that's a to the 3rd. And then we address the b. B to the 1st power minus b to the 3rd is b to the -2. Now, what we have to remember, and we're going to jump down to another rule down here, is right here. If I come from here, negative exponent rules. This is reminding us to flip number, okay? So because we have a negative exponent right here, we're going to flip just the b term. And so this actually comes out to be 1a to the third over 4b to the second power of b squared. So we flipped because this b is, whenever we're flipping, we're thinking of it like a fraction. So it's going to start off on the top, on the numerator, and then flip it to the bottom. Now, as for power of a power, our power rule, whenever we have power to power, we're going to have to distribute. So what's outside the parentheses gets distributed to everything inside. And if we have exponents and we distribute them in, you're going to multiply those exponents. So this is 3 to the third power and b, sorry, to the sixth power. And then I'm going to simplify 3 to the third power, which is 27, b to the sixth. Okay. As for rational exponents, when I'm talking about rational exponents, are referring to fractions. Now you can do all this in your calculator to get to the answer, but what they're trying to get you to understand, if I have a base raised to a fraction exponent, that fraction has a top and a bottom. I'm just going to show you a shortcut. So the top number goes inside the radical, the bottom number goes outside the radical. So top in, bottom out. Okay. So if I have a to the 1/2, this would be written as a to the 1 power with an index of 2 outside the radical. And then our last one here, negative exponents. Remember, this is where the negative exponent is. We want to flip it to the bottom. Okay, so this becomes 6 divided by SR squared. Now, sequences, this one, we've kind of just looked for patterns here. We haven't done anything really major on this, but just look for your pattern. And they'll tell you the type sequence you have based on the pattern you see. So we're looking for a pattern. There is a calculator shortcut, but it's just doing the computation, okay? So arithmetic sequence, the pattern is you're going to have a common difference, and usually that means there's going to be some repeated addition. You're going to be adding every time. For geometric, a common ratio, this means you're going to multiply. Okay. So the nth term of the sequence just means the number term. Not the number itself, but where the term is in the sequence. Like, and I'll show you on this example, but the term you want to really focus on is always the first term. So we have a sequence, A1 equals negative 13. So this is the first number, basically. It's the first term. And then the sequence is A sub n equals A sub n minus 1, but plus 20. So there I'm seeing addition, and I'm adding 20. So all I have to do is do the addition each time to each answer. So you start right here. It says start with the negative 20, and then press enter. So that's in there. And then you're going to plus 20. So this negative, that's it, negative 20. This negative 13 is the first term. If I add 20 to it, this is the second term. And if I add 20 to that, this would be the third term, fourth, and fifth. So we're just showing the math in the calculator of the repeated addition to get the next term. So you can practice that. We're going to practice it on the quizzes. Now, the other thing we want to talk about is factors. Whenever I see the word factor. Okay. So if I see this word factor, you are going to have to use either the X puzzle. Okay. And that's, if it's the X puzzle, that's when we put the C on top and the b on the bottom. And that's when we have standard form, ax squared. Actually, exposal with just c and b means there is no a, so it's x squared plus bx plus d, like that, okay? Or we're going to do slide, multiply, and divide. That's when we do have a coefficient for the lead term. Okay. And then you always have your calculator shortcut. So I just want to explain that here. It says which expression is a factor of x squared, this trinomial x squared minus x minus 6. So this could represent my y1. And they kind of showed that here in the example. And then they put y2 equals 0. Because if I have two equations and I see the intersection of those, I have a solution. So it's telling us that we're going to second, trace, and then 5, and enter 3 times. And once I finish that, this is what I should see on my screen. The word intersection and that intersection point. So this actually has 2 intersection points that we want to identify. Since this first one is -2, 0, this is representing a solution. Okay, x equals -2. Or you can think of it as a 0. Here, this is the other solution, which is x equals 3, which is also like your 0. Okay, now, because the keyword on this problem said factor right there, that's what we have to think and kind of work backwards. When getting factors, this is important. When getting factors from the graph, you have to use the opposite sign. So this is our factor form. Our factor form, or a form that has factors in it, is whenever we have x minus some type of number, and then x minus or plus, okay, some type of number. So what I'm doing, I'm just going to take our value of x right here, put it in factor form, but do the opposite. So since this is -2, then this would be x plus 2, positive 2. Since this is a positive 3, then the next one would be x minus 3. And there is our factor form. So here's a good example. See if you can understand how to get to your solution. So this is which expression is equivalent, there's that keyword again, to 9x squared plus 12x plus 4. So I'm going to pause and give you some time to try it. Use your calculator or do your slide, multiply and divide, and then see if we can match our answer. All right, the answer here was C. So I didn't put it in here, but if you go into one way you can really see it, when you're looking at your graph and you're looking at that intersection, those intercepts, I forgot to put my x. Sorry. And then plus 4. All right, so I can graph. I think I see there's maybe more than one intersection, but what I need to make sure I do is on the second, I'll put a 0, hit my graph, and then what I want to do is hit second trace because I want to find the intersection, which is 5. And I'm going to hit enter 3 times, and we get a -0.6. So this is a fraction answer when I solve it. So, but hopefully we see that there's only one intersection right here, and that's a clue. Okay, and that intersection, let me go back real quick, is a negative right there, so the factors would have to be positive. So that's why it's C. Okay. Or if you're going to do this pencil and paper, you would have to slide, multiply, divide. Okay. So when we slide, we get to 36. Then we get 12 down here. We're looking factors of 36 with the sum of 12, excuse me. And that would be 6 and 6. But then when I write my factor points, it would be x minus 6 and x minus 6. And because we had this coefficient 9, we're dividing by 9. So x if I just reduce this, this would be 2/3. Okay. It's the same, so instead of writing this twice, I can just write it as two factors of the same. But since this 3 cannot go into 2, this is one, I don't know if y'all remember, but this one we do bottoms up. Meaning the bottom number goes up to the front. So we get 3x minus 2. 3x minus 2. Get it twice, which basically just means you can write 3x minus 2 the factor 2, meaning I have two factors of that. All right, so thank you for doing this. Please make sure you get your quizzes done, and your Quizlets are to help you study. Just keep preparing for that test. Thank you.